Hi friends, welcome to my channel Fully Explain MCQ. In today's question, we will see the discovery of electron, and in this case, we will also see the cathode ray tube experiment. Cathode ray tube experiment have helped us to discover the electron and its nature. So in cathode ray tube experiment, there is one glass tube, a sealed glass tube, and in that sealed glass tube we have to take air, or you can say any gas, and that gas pressure should be very low. And in that glass tube there should be two electrodes, and that two electrodes should be very thin metal plate, and that should be connected with a high voltage battery. So this setting should be there to perform the cathode ray tube experiment. So now I will draw here cathode ray tube experiment, and that cathode ray tube. So this is a one glass tube. You have to say this is a one glass tube. This is a one glass tube. Here is a one gap. You can say there is a one opening. Vacuum pump. This is a vacuum pump inlet. And there is a two electrode, and this two electrode, it is made up of the very thin metal plate, and this electrode is connected with the help of battery, high voltage battery. This is a high voltage battery. Okay, this is a negative, this is a positive, this is negative, this is a positive, this is a negative electrode, it is called cathode. It is a cathode, and this is a positive electrode, so it is called anode. Now in this cathode ray tube there is a gas filled, and that gas should be any gas, like there must be nitrogen, there must be oxygen, there must be helium, lithium. Suppose there is any gas, suppose there is a nitrogen gas. Now to successfully perform the cathode ray tube experiment, there are certain conditions. One condition is that this battery should be of high voltage. Voltage should be high voltage. This is one condition. Second condition, that here is a gas, and that pressure of that gas is very low. Very low pressure. The pressure of the gas should be very low, and voltage should be very high. Now when high voltage and low pressure, in that case there is a discharge of electricity through this tube. Means current will flow through the cathode ray tube. Where is a gas? Here is a gas, suppose N2 gas. Because of high voltage, this gas will ionize, like N2 gas will ionize N2 positive plus 1 electron. N2 gas will ionize means the electron will come out of that gas, and there will be one electron and another positive nucleus. Okay, this electron, now here is N2 gas, will be ionized as N2 positive plus 1 electron. Now you know the opposite charged particles are attracted towards each other. So this is a positive, so this is a negative, electron is negative. This electron will flow this side, and N2 positive ion will move this side. Now when there is an electron is going from the direction, this will come from this side to this side. Again it will move from here to here. Again electron will come out of this cathode. That means there is a flow of electricity through the very low pressured gas. That means through cathode ray tube there is a flow of electricity. That means the electron is flowing from cathode to anode. Because of ionization, electron will come out of the nitrogen gas. It will flow from here then to here, and ultimately it will come from this electrode and there is again continuous flow of the electron. Sometimes these electrons will be captured by this N2 positive ion. Then it will become N2 positive ion plus 1 electron gives N2. At the same time, there are so many gaseous ions. There are so many gaseous molecule of the N2. So at a point of time, there will be always electrons, there will be always N2 positive, and there will be some N2 molecule also. But the concentration is very low. Because of that, there is very less hindrance to the electrons, and they will continuously flow from cathode to anode and will reach here to the battery. They will again come to the cathode. So this will establish the flow of electron. Now suppose there is a lot of pressure of the gas. In that case, there will be no flow of electrons or no flow of electricity through this cathode ray tube. Why? This is because of the high concentration of the gas, the ionized particles, that is N2 positive and 1 electrons, will not move to the anode because there is so many hindrance to the electrons, and these electrons will again captured by some N2 positive ions and it will get neutralized. So because of the high hindrance, when there is a pressure is high, the electron will not reach to the anode and there is no flow of electricity. But when there is a very low pressure of the gas, that means there is a low hindrance of the electrons, and that electron can reach from cathode to anode very easily. That's why there is a discharge of electricity when there is a low pressure. Okay, this is a complete explanation of the cathode ray tube experiment. Now, one important thing is that these electrons, when it is flowing from cathode to negative, how the cathode rays are coming out of this cathode, we have to identify. Now these rays coming out of the cathode is called cathode ray. This rays of electrons coming out of the cathode is called cathode ray. This is the cathode ray. To identify the cathode rays coming out of the cathode and it is going to the anode, we have to make holes in this anode. And we have to keep here one phosphorescent material. Phosphorescent material is zinc sulfide. Zinc sulfide is one of the phosphorescent material. And this we will attach here. Now this is a perforated anode. When cathode rays are coming from the cathode, it is moving to the anode. When it is perforated, this will directly pass from here and will hit the zinc sulfide chemicals. That is a phosphorescent chemical. When it is hit by that cathode ray, or it is called electron, when there is a glow of the light. When there is a glow of the light, that means there is some kind of rays are hitting the anode, and that is coming from the cathode. So in this way, we have established the coming of the cathode rays from the cathode and it is going to the anode. So there is establishment of the cathode rays. There are some characteristics of this experiment. Now what are the characteristics? Characteristics of the cathode ray. Cathode rays. What are the characteristics of the cathode ray? First characteristics, cathode rays are emitting from the cathode and moving to the anode. That means from cathode to anode. This is the first characteristics of the cathode ray. Second characteristics of the cathode ray is that it is not visible. Means these cathode rays are coming out of this cathode and moving to the anode is not visible. This is not visible. Not visible. To make its sense visible, we have to keep here zinc sulfide, that is phosphorescent material. When that cathode ray will hit here, there will be the glow, and that glow will tell us that there is some kind of rays are coming or hitting that anode. Now third characteristics of the cathode ray. Third characteristic of the cathode ray is that in absence of magnetic and electric field, magnetic and electric field. In absence of magnetic and electric field, it will move straight in line without any deflection. So this is the third characteristics of the cathode ray. Fourth characteristics, in the presence of electrical field, this cathode ray will move to the positive electrode. Positive electrode. In presence of the electrical field, this cathode ray will move to the positive electrode. That means it is a negatively charged. It is negatively charged. These cathode rays are negatively charged, and it is also deflected in magnetic field in the direction perpendicular to the magnetic field. That means it is deflected by electrical field also and magnetic field. This is the fourth characteristics of the cathode ray. Fifth and very important characteristics of cathode ray is that it is not dependent on the nature of this electrode metal, whether it is platinum, whether it is Fe, or whether it is Ag. It will not depend on this plate electrode, plate metal. And also it is not depend on the gas, which gas we are using here in the cathode ray tube. Whether you change the electrode metal or whether you change the gas inside the cathode ray tube, characteristics of the cathode ray will remain same. It is independent of the metal used in electrode. We can establish that the electron, that is the cathode ray, are the basic constituents of the all atoms. So fifth is basic constituent. Basic constituent of atom. Basic constituents of the atom. So these are the 5 characteristics are very important of cathode ray tube experiments, where we have established the nature of the cathode ray and its characteristics. So friends, this is the explanation of the cathode ray tube experiment. If you understood this experiment, then please like, share and subscribe to my channel. Keep studying. Don't give any gap in your study. Study hard, and study hard so that it will open your mind, and try to be employer, not a employees. Because if you become an employer, then that time there will be the freedom of money and freedom of time. So this should be your goal in your life. So friend, thank you for watching.